Good morning, folks. I am in Franklin, Wisconsin, but if we can rewind probably 8 years ago, I had the chance to walk into the Deutsches Museum in Munich, Germany. And if you ever have the chance to go, it is, I would say, the single best museum in the world. And they have a huge emphasis on manufacturing. Obviously, as Germany has a huge history with manufacturing, this museum has everything from historical manufacturing to automation. There was a molding demo that kids could watch small mold parts being cast, and they had a Hermle. The first time I ever saw a Hermle, and I later heard from a friend who had sort of said, oh yeah, those are some of the absolute best high-end 5-axis machines. Fast forward, over the past 5 or 6 years, I've gotten to know Gunther and Matthias and the team here at Hermle. Their hospitality is second to none, and their machines are second to none. I finally had the chance to come up to Franklin, Wisconsin. I wanted to ask if you guys would show me around your U.S. showroom.
We'd love to show you our showroom. Welcome to our newly renovated technology center here in Wisconsin. As you can see, it's pretty much everything is brand new. Still smells fresh. And so what we've got in here is we've got about 7 machines, all fully 5-axis. 3 of them are actually automated, and we'll walk you through, we'll show you everything, and very excited about it.
And I can tell you, as somebody who has moved from the sort of traditional machine shop side over to the automation side, you know, we've got the horizontal with the pallet pull, we've got the 5-axis with the pallet pull, the Wilman is a bar feeder. The world is never the same. I will never, ever look back. It really is. I want to hear you guys show off the Asus Flex and the RS. Do you have an RS here?
Yeah, we've got an RS. Actually, we have 2 RS here. We've got the RS1 sitting right here.
Okay.
Obviously, that's a system that can handle parts as well as pallets. Then we've got a smaller one, an RS05 sitting here, and we've got the big HS Flex Heavy for the bigger stuff, for the die mold guys. What we did actually is we kind of broke it up. On the right side, you have the 3-digit line. So we've got the performance line machines on the right side, and we've got the high performance line machines on the left side. With the exception right now, we've got a C250 sitting here with the brand new TNC 7. The reason why this one is sitting on this side is because we're doing some testing with a new TNC 7. But otherwise, on the left side would be high performance line machines, whereas on the right side, we've got the performance line machines. So this is the foundation of our 5-axis machine. You've seen it during the factory tour in Gosheim. So we've got the mineral casting base, which we also obviously produce in-house. We've got our own foundry, mineral casting foundry, where we actually produce these bases. You got the 3-axis, it's a modified gantry, so we have either depends on the model, 3 or 4 rails in the Y-axis direction. You've got the tool changer mounted right in the center for ideal weight distribution. Obviously thermal symmetrical design, and Trodian is integrated into the machine space.
All of your machines are made in Germany?
All of the machines 100% made in Germany. Yeah, we don't produce any machines abroad, so it's all abroad, in other countries.
Yes,
let's put it this way. So 100% German made. And obviously, we're what I consider vertically integrated company, so we like to do things in-house rather than outsource. I'm sure you've heard that before.
Yes.
That's the reason why we have our own foundry, our own fabrication shop. I mean, you name it. The only thing we don't do in-house is powder coating, but other than that, everything is done in-house. That we believe is important when it comes to, longevity of the machine, the precision, overall, important features actually.
Gunther and I had the chance to do a tour in Gosheim, and video that ended up being tremendously successful. It's quite long, but it has a wonderful story showing that. And I think the comment that made me chuckle was that you have more Trump machines than Trump had or something in that section.
I always refer to it as the Trump showroom because, we got it all, and it's quite impressive. If you haven't seen the new fabrication shop, but obviously I'd like to extend the invitation. We just opened it about 2 years ago, and it's a very clean shop, and like I said, everything they make we pretty much have.
One of the things I wanted to raise attention to is the things you don't necessarily appreciate when you don't see a machine maintenance. You only see machines that are on. But number one, mineral branches are incredibly rigid and stable.
Yes.
And the way the kinematics are designed with that sort of additional third rail in the top.
Yeah, exactly. So especially when it comes to when you're machining more critical materials, such the the super alloys of the world, you're doing a lot of titanium. The way the machine absorbs the forces that are being generated during the milling process is ideal. And at the end of the day, that will result in much longer tool life, which at the end of the day for you as a shop owner means, cost per piece is going to come down, more money in your pocket. I mean, one thing you can see here is like, even with one hand, I can actually move the slide.
Oh, that's really cool.
And so what's important to understand, no matter where we at within the working area within space, the distance from, let's call it the support or the x-axis to the center of the spindle doesn't change. Whereas there are some kinematics, you come out with a head, right, the further you're out, the less rigid it becomes. And that isn't the case with this design. But then again, thermal symmetrical is also important, and what's even more important in our view is obviously a lot of the builders, they became assembly houses over the years, whereas we like to do it ourselves, and we like to machine all the critical components in-house rather than outsource it, because in our view, that's the only way you can control the quality. The C400, that is the machine that we mainly use for actually training, so we've got weekly training classes set up here, so we bring our customers in. We also do on-site trainings, but we actually like to bring the majority of the customers in because they get less distracted when they're here for training, whereas on their own shop, right, people call you and there's always something going on. So, but yeah, this is the C400. That's the machine that we mainly use for training.
Sure enough, so easy to get right up.
You get right there, yeah. And obviously you can open the roof. Okay. So you can either, there's an auto version, or you just manually release it, open it, release it, and it goes all the way there. We also have what we call a load function, so we can actually move the spindle into the magazine. So spindle moves into the magazine, and then you can actually open the roof and fully retract it. So, and your wife is going to appreciate that, because you can actually walk in, you're not going to smell like coolant when you get home because of all the coolant.
The full effect.
Yeah, I like that. That's nice. So that's Matthias's baby, so I'm going to hand it over to him, because actually it was his project.
So this is our C250 with the RSO5 robot. One of the things that we just saw during COVID, certain industries went down, other industries went up. So one of the things we wanted to do is work on a gun slide. In here you can see a couple of finished parts, but mainly stock. So we wanted to get a really part dense matrix here, just to allow longer run times.
Right?
Yeah.
Yeah.
I think we're at, 3 days?
About, yeah,
I think
close
that's where we're at, 3 days.
And that's one of the things that I've sort of learned now with automation, is that having individual pallets or even large tombstones can take, frankly, can take hours, even a whole day to reload it. I can already start to understand being able to walk up to this and in a matter of seconds or minutes, pulling parts out and putting the parts in.
Yeah. So theoretically, they're treated as two different matrices, so you could run two separate parts, or you can run the same part. Obviously, while you have this one done, you can unload it and pack it up with new parts already. You can also define, hey, I'm only loading 8 parts, so the flexibility of what you're really telling the machine what's in it and available, or you're taking out, is really up to you. Really, from an operator's point of view, you don't need an extremely skilled person to just load up a machine and get it going. Obviously, on the setup side, initially, that's a different topic, but the idea is that I could have somebody that is not as trained, but still load up the machine and just keep the machine running. Really, once
from Hermle would come the robot with the end effector, with the flip station, etc.
Correct. So, I mean, obviously, we can configure the machine in several different ways. Generally, what happens on projects like this is there's a lot of back and forth between Hermle and the customer to get everything worked out prior to the delivery of the machine. So essentially, once it actually gets there, we can do training on it and we can get everything set up and the customer can start running right away. But a lot of customers actually buy the machine with the universal matrix.
Okay.
With the universal matrix, as long as you're just working with block material, the robot picks it up, places it into a vise, and that is rather easy to set up.
Okay, so this one could not be switched to, say, 3-inch round slugs.
Absolutely. It's just a matter of then adjusting the gripper to have a proper gripper
Okay,
to hold it, and obviously the work holding on the inside.
So
the gripper fingers are adjustable, and so you can update it.
No, and I mean, we do offer several different variants of the inserts here. I mean, other customers have also made their own inserts to suit their needs. It's just a matter of planning that through, kind of understanding, okay, what am I starting with and what am I left with after the fact.
Obviously, the majority of the customers that are into that business, they actually use 4-axis horizontal machines, right, to make them. So one of the tasks or one of the challenges that I presented to Matthias at the time, I said, I'd like a system where, that doesn't require a PhD to run, and where you just put the bar material in and you walk away for like 3 days without any manual interference, because we can't compete with a 4-axis, 400 millimeter horizontal. We're obviously more money. But when you look at like unmanned machine time, then we can actually we can compete with these systems. And we even do the broaching on it.
Incredible.
Yeah. So this is how it comes out.
Yeah, really impressive.
Put the material in there, you load it, close the door, and you walk away.
So yeah, so in this configuration, it will grab a blank part and then insert that into the machine. Machine works on op 10. Once the cycle is complete, the robot will grab another part, go into the machine, grab op 10, flip it around, put it in op 20, then insert op 10 of the second piece into op 10 work holding station. Then the cycle repeats over. It works on both sides. And then on the very next one, it does the same process, but you're going to get a complete part out of it. Correct.
Yeah, that's awesome.
So we can also take a look at the work holding side here. So here you can see the fixture itself. Really, op 10 is a pretty straightforward clamping vise versus op 20. We did a little bit more just to make sure that the parts seat correctly.
Yeah, it's a tricky, not party too much.
That's the magic in there.
Yeah, sure.
But don't get too close. So yeah, really the goal here is like, to pretty much load up the cell, walk away for like 3 days and bring a slice.
And again, I'm now living in that world of having a horizontal, and there's some benefits to it, but if one clamp on one tombstone location causes a problem, that can put us down for hours or longer to break through. Like I see the benefit of a one-piece flow that delivers products and throws stuff in. I like that.
Right. And obviously, with all the the probing capabilities that we have with the laser, we can really control the process. It dials itself in, and because at the end of the day, that's what you want. You want to be able to walk away and let it run, rather than having people there working with comp tables to adjust to get the parts right. And we have the 5-axis technology in order to do that. Even though technically, when you look at the part, you think first off a 4-axis horizontal, right? So it's not essentially a true 5-axis part.
I think one of the biggest things that we looked at when we did this project is, well, yes, a horizontal is going to make that part, probably going to make the part a lot faster. However, you need a person to feed a fixture. When you're feeding a fixture manually, there's inconsistencies. Operator on Monday might not be the same operator on Friday, so there's inconsistencies. And even though the cycle time might be a little bit higher than a traditional process, that continuous flow, pretty much as long as you can supply with raw material and replacement cutters, I think becomes hard to beat.
And it's what Gunther said a minute ago about you can also kind of make the argument that the accuracy and quality of a Hermle may be more than you need on a traditional part like a firearm slide, but the counter that I've heard to that, which I love, is that I want my second slide and my 202nd slide to be the same. I want the tool life to be the best. And so that's where all of a sudden that precision and build quality matters over the course of a manufacturing run.
Yeah. And Matthias always says that, I mean, we really pride ourselves is like, the first part gotta come out right? We don't want this tweaking, moving datums around and such in order to get a good part. And with the technology we have, even though again, it probably more suits itself for a 4-axis horizontal, but with the technology we have, we can actually implement that, use it, and so to assure that the first part comes out right. We can use the capabilities of like aligning the trunnion within space for up 20, right? So it gives us a lot more freedom, I guess that's what I'm trying to say.
If you wanted to, I don't know if you got the chance to look at the empty machine when you were in Glussheim. So we're only going to do a control run, but at least you get to see her spin. We're going to decrease the RPM that we'll start out with, generally always down to the lowest. So for us, that's going to be 25. So now the table becomes the spindle. Again, we start out with the lowest RPM, which is going to be 25 for us. And then we just keep incrementing it up. Really, the purpose of the control run is to find the maximum speed of the maximum safe speed of the workpiece. So right now we're at about 300, and on the C42 we can go up to 800 RPM.
Oh my God! But there's a safety mechanism in terms of vibration analysis that won't allow it to.
Correct. So if it actually ever would go over the max limit, the machine is going to stop.
That's a lot of surface footage at the end of that chuck.
So, and we're just about to hit 800 RPMs there.
Wow.
And obviously we can do the turning on what right now the table is sitting at A0,
Sure.
but we can do it at A-90, up to A-130, any angle in between. As a matter of fact, we can actually rotate the trunnion and do what we call simultaneous turning.
Yeah, right. And if anybody is on the fence about how amazing these machines are, we'll splice in some footage from Losheim showing the kinematic motion. I believe that was a C30?
I don't remember. No, it was a 42. I think it was
40, okay.
a 42,
But
yeah. Where we made the pretzel for you?
Yes.
Yeah, that was a
Just
42.
incredible.
Yeah,
Absolutely incredible.
So yeah, really the control run will be used to determine what is the maximum safe RPM, and then you will go over into the balancing mode. And at that time, you balance the machine at the maximum safe RPM, or at the max RPM that you want to run. We then adjust the weights according to where the control will tell us.
Okay. But I was going to say, you are actually balancing this like you would balance a tool holder or a bearing, spindle shaft.
If you actually look at the table here at the bottom, there's movable weights right on the bottom here.
Sure.
Those can then be adjusted whatever imbalance you then have.
And the control tells you how to move those.
Control will tell you after the balancing run where to move the A weights as well as the B weights. If you end up getting into a higher imbalance where the weights are no longer sufficient, there's also a method of adding or subtracting weight onto a fixture by either blocks or drilling away material.
Then over here we got a C650 again, so that's a performance line machine, equipped with HS Flex Heavy. So this one can handle about 1200 kg, so that's like 2,400 pounds. So for like heavy, bigger components, and we actually have a part in here. It might look familiar to you.
Oh my gosh, yeah, it's incredible.
It's
Molded
that we together, yeah.
Yeah. The thought that that's being robotically loaded and unloaded is really incredible.
Let me open the door real quick. But so we did that part together with the guys from Tevis, and Hermle was involved, and Moldino.
Yeah.
And I mean, just look at the blends and
Straight off the machine.
straight off the machine. Yeah.
I mean, the imperfections you see are really just dust in the air. Just incredible. The blend lines. I know, Matthias, one of the first times I met you, you talked a lot about power mill and how you were so particular about transition lines between tool paths and the linking moves.
I mean, I think like with everything, the eye always is kind of the first judge. And just think back to my apprenticeship days, right? You can make a block that might be out of tolerance. If it looks good, you may or may not get the error. However, if the block looks bad, horrible marks on it, that inspector is going to go around and around that block and measure every single detail, and it's probably not going to go through. And really, in the die and mold side, you know, if you have good blend lines, you have good flow lines, people are going to like the part a lot more than they will. I mean, all in all, and especially on the plastic side, most people polish afterwards. However, if you can start out with a very good surface finish already, it just makes that polishing go that much better.
So obviously, while he's operating the machine, this system or this part here is fully operational. Sorry. So you can actually load and unload parts here while Matthias is setting up the machine.
Yeah. So in order to tie the two systems together, we'll go ahead and unlock the door. Internally here, there's a safety switch. Obviously, once you press the switch, you're telling the machine system that there's nobody in the envelope and it's set to run. You press that. It is a timed event. Once the door is locked, we'll energize the system, and at this point, the two can couple together. In order to couple them together, we'll turn on the automation system. So at this point, we're linked, and now we can either go to the panel on the loading station, or we just pull it up on the control side.
Here. That's nice.
Correct. And we'll just move one of them.
Oh, that's fast.
So right now what it did is it kicked it up. It ensures that the pallet is actually released from the clamping mechanism. Then the robot moves in to actually grab it, and then we'll place it where it finds space.
You can handle different size pallets within an HS Flex Heavy. No different than what we already know from an HS Flex, the smaller version of this system. And it's an important feature because, I mean, at the end of the day, if you do 5-axis components, you don't want to do like a lot of small stuff on a big pallet, right?
Absolutely.
Because then accessibility becomes an issue.
I'm really impressed with how quickly that moves in and out. That's great.
Should we take a look at the C250, Matthias?
Yep.
Probably 5 minutes left.
Okay, yeah. Well, maybe we walk through this area real quick and then we do a C250. Because
this is a showroom.
This is showroom. Yes, we do turnkeys here, we do test cuts, people come here for training. Yeah, you name it.
It's a beautiful building.
Thank you. No, we're very proud of it. So this is the apps area. That's pretty much, and I'll let Matthias walk you through. This is where we set up everything, and we've got obviously all high Mercedes. We got group rally corner for visual inspection.
We go in?
Yeah, of course.
Yes. I mean, pretty much what we try to do is we try to keep on hand anything that we might need for test cuts, different tests for tooling. Sometimes customers approach us, they say, hey, I'm having some issues with this. Can you guys help us out with that? Just to be able to throw a block of aluminum on the machine and run a program potentially helps out a lot.
And that's a big difference. Stepping up to a machine like the Hermle is the sales process is not just buying the machine. And I'm not going through this process, but I know it through talking with them and the folks that have bought like index style machines. Is there's a whole runoff procedure. You work with the customer, you tool it up, you run test cuts. You may run the part here, you may run the part once it's on the factory floor, the customer's floor. It's a very much different than just.
There's a lot of different flavors of how this can go. I mean, some customers, especially existing customers, they just say, "Hey, I need a standalone machine. This is the configuration I want." We might have new customers where we then interact a lot with saying, "Hey, you know, this is really what we saw that works best," to the full turnkey side.
I mean, at the end of the day, we always say it's not just a machine, right? You know, it's the fixturing, the tooling, the programming, and that's why, we got all this here. And I think that it's very important.
Yeah. I mean, the one thing is obviously we can, machine, we know what we can get off the machine, but measuring equipment and all that is always kind of, you need that support equipment in order to really do that. So same thing on the work holding side, on the tooling side. You kind of have to start with the right items, you have to end with the right items. So that's really what this area is all about.
Should we take a quick look at the new TNC 7? Yeah. To our knowledge, this is the first TNC 7 in North America. we're very proud of that. Oh yeah. Yeah, that one was late and it wasn't cheap to get it in, after our original move-in date. But yeah, so.
I think I might like the RS one better
than the TNC. Oh yeah, this is small. It can do a lot, but obviously there's a learning curve to it. But in terms of flexibility, I think it's unmatched. There's nothing else out there. Obviously, the configuration that we've got here is we can handle different size materials. We can do the laying vices in this interface. We can do a robot pallets, all different sizes. You name it. We have what's called an adjustable vise. We have an adjustable gripper. I think this is in my view, it's the highest level of flexibility that you can actually reach.
It's actually a great size footprint too. I haven't really appreciated that before. For what that machine is, it's a relatively...
Yeah, certainly small footprint. Obviously you've got the chip conveyor on the left side. We've got the coolant through system behind it. We've got the Mystic strap up there. But yeah, very, very compact footprint. And what's also, in our view, always important is that you're actually able to access the accessories, right? In case something does go wrong, you don't want to take the entire machine apart first, right? So you want to be able to, check a valve, check a pump, right? Without taking the machine apart.
That's high pressure?
This is high pressure. This is a 40 bar unit. You can also do 80 bar, which is like 1100-ish PSI. So
where's the flood coolant tank?
So it actually is both systems. So you do have a high pressure pump right here, and then you have the external coolant supply here. And depending on the machine configuration, you can have bed flushing. All the coolant really comes from this tank.
That's just the
conveyor. You have the conveyor, but there is a drain tank at the bottom. Once the drain tank fills up, the pump will carry back through the paper band filter. Through the paper band filter, it then cleans up the coolant, and then it becomes recyclable.
In October, we're going to have a 5-axis summit. It's going to be the first Hermle 5-axis summit here in North America. Obviously, I'd love to invite you guys all. It's going to take place October 3rd till the 5th, and if you're around, love to have you here. We're going to show all the 5-axis technologies. We're going to have tech talks. Obviously, we have going to have at that time 8 machines, 3 of them fully automated. So we'll talk automation, we'll talk engineering. We really want to make it an engineering event. So that's what our goal is.
Can we just put a link? Is there a sign-up
Yes.
link or something?
Yeah.
Okay.
Actually, next week we're going to launch. You're going to see a few things on social media, and then you can RSVP. So again, you guys are all invited. And obviously, timing is perfect because October means Oktoberfest time. So that's going to be good German beer, good German brats, and like I said, love to have you guys all come. That was one of Matthias' latest projects or parts that he put together or worked on.
Cool. Yeah.
You may want to say a few words on actually how you.
So really, we needed something for the Mexican market, and the calavera is just, I mean, I wouldn't say an integral part, but pretty much everybody that can identify with that.
Sure.
So really start out from a blank square. We put a
Interesting. The work holding.
get a grip work holding system,
Okay.
just because we wanted to have something pretty small and narrow so we can get as close to the base as we can. Obviously, there is an op-10 to this. We machined down a little bit of the base, but then really the rest of it is all machined in the top setup. Then it went out for anodizing, and then we did the engraving.
Okay. So you didn't just machine the gravy, you machined the whole thing and then came back.
Correct.
Yeah. Can you show, is that a cleat or how does that work?
So in here, once you turn the screw, it just essentially thins the wedge, grips down the part. So like a dovetail, but you also get X and Y clamping, if you will, because of the wedge.
You don't have dollars that you're pulling down. And so on that part, your A goes well beyond 90 degrees. Is that the case?
It goes to 110, I believe.
Okay.
No, so on the C250, we get minus 150 plus 150 degrees.
150.
115.
115.
Both
Okay.
directions.
So yeah, we did only work in the minus just because it is a demo part. With the plus orientation, it's just in the plus orientation, it becomes pretty tough to see. However, it is pretty beneficial if you think about it, a spherical part. If I want a 5-axis mill that and go over the sphere, if I don't have equal travel in both directions, well, at 0 usually most posts then stop, do a rotation move, and then continue, or even do it on the part. And obviously there's always some pressure, and any stop, you'll always see it. But with the equal motion, you can get around the sphere.
Yeah. Point of singularity are important. Well, Gunther, Matthias,
Thank you, John.
great to see you.
It's a pleasure.
Great to see you.
Thank you.
Thank you very much for joining me. As always, folks, hope you guys learned something. Hope you enjoy. Take care. See you soon.